Hello everyone. In this video, I'll be touching on the next part of the chapter or discussion of logarithmic and exponential functions. In this case, I will be talking about the graphs of exponential functions. So I'll give you an example of how do we sketch y equals 3 raised to x exponential function. So let's revisit first how to sketch any random graph. Um, it's really important for us to remember, recall back how we sketch straight line functions, linear functions, quadratic, and so on. So um, table of values are definitely important, right? Table of values are the very first way whenever we want to sketch a graph. But then aside from the table of values, we learned back then that it's really important for us to know the characteristics. Now, but then what does it mean by the characteristics? What are we referring to when it comes to characteristics? There are a lot of them. Like for example, if it's a linear function, we know that we only need 2 points, right? And then usually we look at the intercepts. Usually, not always, but in most cases probably the intercepts. But in the sense of quadratics function, for example, we can, or we at least need more 3 points or even more. We can look over the intercepts if there are any, and then we also find out whether there's a vertex or not, and then we figure out when if let's say this is the generic equation, if the a is more than 0, we know the shape look like this, a less than 0, the shape look like this, and so on. So intercepts, the vertex, and then the look of the shape in general, those are usually the characteristics that we're looking for. So then here I'll introduce you probably the third one, the third characteristics that we can look for aside from intercepts, very common, the vertex if there is any, but also the third one is that like the tendency of the graph, see, of values or the graph, which I will introduce you in this case. So when you're talking about y equals 3 raised to x, let's just use the table of values first because we've never touched on this typical function, right? Let's say, because 3 raised to x is simply exponentials, right? It's just powers. So let's go from 0, for example. 3 raised to 0 is 1. 3 raised to 1, 3. 3 raised to 2, 9. 3 raised to 3, 27. 4, 81. 5, 243. 6, 7 to 9, and so on, right? The same is true if, let's say, we have the value of x to be negative. So we come from 0, let's say we take -1, just take the easy numbers. 1/3, -2, we got 1/9, you can look over calculator. -3, it's 1 over 3 raised to 3, or 1 over 3 cubed, that's 1 over 27, before 1 over 81, and so on, right? So then this gives us an idea that the tendency is that as the x goes higher, here also goes higher, right? But when this goes very small, this one is actually goes very small as well. But then not only that, knowing that the pattern is go higher, higher, smaller, smaller, yeah, yes, but then also look at the tendency of the values. When in this case, whenever you look at the numbers, it keeps on increasing infinitely. So like it becomes so big that you probably there is no limit up to it. But then whenever you look at this number, it gets smaller, smaller, smaller. But think about this. Will this be negative at some point? Or maybe not only negative, will it be 0 at some point? If you try to look at the tendency, it will not. It will be just very, very close to 0, but it will never be 0. Never be 0 for y equals 3 raised to x, right? So in that case, so we have to look at the tendency. So then whenever we want to sketch this graph, so then it's something that we can take a look. These are the notes for later. Let's keep it safe. Y equals 3 raised to x. You see it earlier. It's 1, 2, 3, 4, 5, and so on. It's increasingly becoming bigger and bigger, right? 1, it's 3, and probably it's already here at 9, then and so on, right? Or if we change the scale, probably it's here, probably here, 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 and so on. So then as it gets smaller, it gets very, very small, but will never touch 0. So then it becomes a curve, then it becomes something like this. My drawing is really bad. Sorry for that. So if I try to connect the dots, will look something like this probably. So this roughly y equals 3 raised to x. And of course, whenever you wonder like, sir, how about y equals 2 raised to x? It will roughly be the same, but maybe not as steep as that when it comes to the changes. So probably it's something like this. So it will roughly look the same. If let's say we have it like -1 over here, in other words, this is like transformation idea. Whatever value of y that you have, you bring down by 1. In other words, you probably will come up with this type of graph. So then it touches, it has the intercept, but in this case of number, it will never touch y equals -1 instead. Here, never touch y equals 0. So here in this case, the lines that they will never touch, we call this asymptote. Okay, we call this asymptote. That is a new vocabulary. So a line that will never touch, a line that will never be touched by the graph as x goes to infinity, for example, or x goes to -infinity, or so on, or other stuff. There are many types of that. So it will never touch, no matter how long you go, it will just never be touched. So in summary, when it comes to exponential functions, for example, domain and range, of course, part of it. If let's say we have any random exponential function in the form of this, in general, it's something that you can take note for yourselves as a note, that the domain can be anything. I think that makes sense. The x could be just any value. You can plug in for any value, but the value of the y can't be any value, right? As you can see earlier from the example, it will never touch. See, never be touched, all right? So that's why the range is, sorry, I want to erase this. Y more than c, or fx more than c, and then it's called asymptote, and in y equals c. Now, if the value of b is positive, like this case is positive, the graph will look like this. This is when b more than 0, for example. But then when the b is less than 0, for example, this, so then you see it's a bit different. The graph looks different. So it's something that you can explore further, but there's like a rough idea of how we know the graph of exponential function, or how you sketch exponential function graph. So we can explore it further. You can get a help of GeoGebra or Desmos or any that similar graphing software to get better idea of the visual representation of different graphs for exponential functions. Thank you.